Alright, we're going to do the 153 sample final. So if we have an 8.5 by 14 sheet of paper folded along the edges like we've done in class, that's a piece of paper. We're going to have to cut corners out of it, or at least fold it, so these are not going to matter. So the bottom's going to be something like this, and we're going to fold these up. So we don't know how big each of those are going to be, but they're going to be same size in both directions. And if this is 8.5 inches and this is 14 inches, then the length will be 14 minus 2x. 14 is the whole length, back off x and back off x. This would be for the 14 minus 2x. The width would be 8 minus x and minus x. 8.5, I should say, minus 2x. And the height will be how high this each are folded up, which is x. So the volume is, it's equal to x times 14 minus 2x times 8.5 minus 2x. So, this is what I'm supposed to do down here. So this goes here. I didn't pay attention to what I'm doing here. The length is going to be 14 minus 2 of these 1 3/8. 1 3/8 plus 1 3/8 is 2 6/8, which is 2 3/4, or 2.75. So 14 minus 2.75 is 11.25 inches. This would be 8 minus 2 is 6.5, minus 3/4 is 5.75 inches. And this would have to be the height, which is the 1 3/8, or 1.375 if you change 3/8 to decimal. And these multiplied, 11.25 times 5.75 times 1.375 is 88.94 inches cubed. 95, I guess, rounded off properly. And this is the formula with x's in it. Use technology to find the max volume. So I go to my window and I type in x parenthesis 14 minus 2x and 8.5 minus 2x. And if I go zoom 6, probably won't see much. It goes off the screen higher, so I need to see higher maxes in the y. I'll make it 500. So it goes up, hits a max, it comes down, and goes, and it goes down, it hits 0 at, looks like 4.25 maybe, which happens to be half of 8.5, it's 4 1/4, and that makes sense. So write a formula, technology, the x that gives the maximum. Second, calculate the maximum, that's between 0 and 4. 0, enter, 4, enter, and guessing 2-ish. It says 1.714. 1.714 is the x, or the size to cut that piece, inches. So the maximum volume was 91.91 cubic inches. Describe how the x-intercepts relate to the box. This is when we don't fold anything. Which means we're going to have 0 volume. This is 4, which is 0, which is going to have 0 width, because if we take 4.25 off of one side and 4.25 off the other side, we've used up all the 8, and the width of the bottom of the box would be 0. Width of bottom of box equals 0. And the last intercept there is at 1, 2, 3, 4, 5, 6, 7. And that would be when, if we take 7 out of this side and 7, that makes the length of the box 0. So that's what they each have to do with this problem. Car gets 30 miles per gallon. Miles per gallon. And drives 50 miles. If the distance, D is the distance, G is the gallons, and T is the hours, write formulas. Given the number of gallons, how far can it go? Well, if it goes 30 miles per gallon, if we take, that's miles per gallon, if we take it times gallons, the gallons will cancel and we get the miles. So we're going to take the 30 miles per gallon times the number of gallons, and that's a function of G. D then becomes a function of G. D a function of time. Well, 50 miles per hour, if we multiply it by hours, time, we'll get the miles. So D will be 50 times the time. If we're going to reverse this, we have to reverse this. So this says the distance is 30 times the gallons. So if we're going to find the gallons, we have to divide by 30 on both sides. And so it's the distance divided by 30 gives us the gallons. And here, if we have miles per the distance equals 50 times the time, then if we want to find the time with the D is in the equation, we have to divide both sides by 50. And time as a function of D is D over 50. Now if we want to find time as a function of gallons, well, the only one of these that takes G as the variable is this one, and that gives us D, and we're supposed to end up with T, and this one takes D, so it's going to be this function that we need to use, the D divided by 50, but to get D, we're going to go using G, we're going to have to do 30G gives us D, and D in for here makes this. Alright, so to do this one, type in the equation, 5x to the 5th minus 42x to the 4th plus 101x to the third minus 54x squared minus 52x plus 24. Zoom 6. And looks like I may have typed something wrong. Oh, I did. Delete 5x to the fifth, delete the times, minus, this should be subtract, 42x to the fourth plus 101x to the third minus 54x squared. I must not have deleted my last equation. Okay, there it is. Now it's graph. Okay, so let's go zoom 4. That'll be a little closer, a little better view. Looks like we might have a minus a half. Not sure about that one, and something between 0 and 1. But does look like at 2 is a bounce. So I'm going to go 2 with a multiplicity of 2 because of the bounce. And it goes through someplace here. So now I need to find these other ones, see if any of those are nice. And this would be 1, 2, 3, 4, 5. There's all 5 of them, degree 5, so we're okay there. So let's see if any of these turn out to be nice numbers. So second, calculate the 0 between -1 and 0. And I'm going to guess -0.5. And it says no, it's at negative 0.645751. Ugly number. Don't like that one, so to get that one exact, we're going to have to do something. Let's go to the other one here, between 0 and 1. Second, calculate the 0 between 0 and 1. Guess 0.5. And it says, nope, it's 0.4. But 0.4 is nice. 0.4, which is 2/5. Happens once, it goes straight through. Okay. So we have 1, 2, 3 of them out of a degree 5. If we do synthetic division, we'll get it down to a quadratic, and we can find these other 2 using the quadratic formula and get them exact, because they want exact. So, synthetic division, I have 5x to the fifths minus 42x to the fourths plus 101x to the thirds minus 54x squareds plus minus 52 x's plus 24. Got all the powers. 5, 4, 3, 2, 1, 0. Want to make sure we have all of them. If there's one missing, we have to put in a 0 in for it. I'm going to do 2 first, and I'm going to do it twice. So 5 plus 0 is 5 times 2 is 10, which is minus 32. Minus 64, that would be 35 times 2 is 70. That would be 16 times 2 is 32, which should be minus 20. 40 didn't go in evenly. I made a mistake someplace. 5 minus 42, 101, negative 54, negative 52, 24. 5 times 2 is 10. Add that to the negative 42, I get negative 32. Times 2 is negative 64. And 64 is 37. There we go. 37 times 2 is 74. And so that would be 20. Times 2 is 40. and that would leave minus 12 times 2 is minus 24 and 0. Okay, now 5 plus 0 is 5 times 2 is 10 minus 22 is minus 44. That's minus 7 times 2 is minus 14. That's plus 6 times 2 is 12, 0. That's how many times I expected to go in evenly. And now I'm going to do the 0.4. 5 times 0.4 is 2. Add, I get minus 20 times 0.4 is minus 8. That would make minus 15 times 0.4. 15, that would be 6 minus 6, which is 0. I think that's right. Negative 15, negative 15 times 0.4. Negative 6, 0. Okay, and I see there's a 5 in all of these. I see there's a 5 here, so on my factoring, so far what I know is f of x, or y, equals x minus 2 twice x minus 0.4 once, and if I factor out a 5 out of this, I get, this is x squared minus 20x, so if I take a 5 out, I have x squared minus 4x minus 3, and so I'll do the quadratic formula on this. The opposite of b plus or minus the square root. B squared is 16 minus 4 times minus 3 is minus 12 times 1 is plus 12 over 2 times 1, which is 2. 16 plus 12 is 28, which is square root of 4 times the square root of 7. Square root of 4 is 2, so 2 will go in the 4 and make 2 plus or minus, and 2 will cancel the square root of 4, which is 2, and plus the square root of 7. So my other two answers are 2 plus the square root of 7 and 2 minus the square root of 7, and they each happen once and they go straight through. And so finishing my factoring, it's x minus this, minus 2 minus the square root of 7, and x minus this, which is minus 2 plus the square root of 7. And there it's factored. Now that was supposed to go there. And looking at the graph, when is it greater than or equal to 0? Well, this came up, went down, came up, down, and went up, so it's greater than 0 beyond this place, which is 2 plus the square root of 7, and it's greater than 0 from there to there. So greater than 0 from there, which is 2 minus the square root of 7, including it to be equal to 0, up to 0.4, and then at 2 only, 2 to 2, that interval, or just a 2, union, and then beyond 2 plus the square root of 7 to infinity. Models the height after it's kicked. What's the height of the football after 2 seconds? We just plug 2 in here, so we have negative 16 times 2 squared plus 40 times 2 plus 5. So 85 plus 4 times 16 is negative 64. And so that subtracts to be 21. And this is in height in feet. What is the maximum height the football reaches? That'll happen at the time minus b over 2a, or you can go to the calculator and type it in. Negative 16x squared plus 40x plus 5. Graph goes up, comes down, happens in the middle. Second, calculate the maximum. That's between 0 and 2, and let's say 1. And it says it's at 1.25, and it's 30 feet. At time equal 1.25 seconds. How long is the football in the air? Well, if it's 1.25 to the top, it's another 1.25, or 2.5, which is there. Second, calculate the 0. That's between 2 and 3. 2, enter, 3, enter. And it says 2.61, so it's not quite exactly 2.5. 2.62. Alright, let's simplify these. Cube roots, so we're taking groups of 3. So 3 of the x's will come out as an x times the x that's already out there, so we're going to have 4x squared. It's an odd root, so we don't have to worry about that. Negative comes out of an odd root. And 54 is 6 times 9, which is 2 times 3 times 3 times 3. So 3 3's will come out, so that'll multiply by the 4 and make negative 12x squared. And what's left inside? Well, a 2. And we took 3 of the x's, so there's x squared still inside. Square root. 3 x's, so we're going to take 1 out. And since it's an even root, we need absolute value on it. There'd still be the square root of x in there, and 24 is 2 times 12, which is 2 times 6, which is 2 times 3. Square root, we'll take a pair of 2's out as a 2, and there'll be a 6 left inside. Next page. Okay. I can factor that, but I can also just type it in case I'm worried about my factoring skills. So x to the third minus x squared minus 6. Crosses, minus 6x. Didn't look like it was nice numbers. Crosses at minus 2, so x plus 2. Crosses at 0, so x, and it crosses at 3, so x minus 3. Now I could have just pulled out an x out of this, and I would have had an x squared minus x minus 6, and this factors to x plus 2 and x minus 3. The denominator, I can pull out an x, and I'll have an x minus 4 left, x and x minus 4. So there's going to be a whole at x equals 0 because those are going to cancel. So at 0, and to find out how high it is, I put in 0 into the rest of this, which would be 2 times a negative 3 over negative 4. So that's negative 6 over negative 4, which is positive 6 over 4, or 3 over 2, 1.5. Determine any vertical asymptotes. Well, there's not going to be one at 0 because that's the whole, and there's equal numbers. So there's one at x equal 4, and I didn't ask for the behavior, but I'm going to note that this happens only once, so they go in opposite directions there. Bonus points possible. Determine any horizontal. Well, the degree of the denominator is less than the numerator, so I need to do long division. X squared minus 4x into x to the third minus x squared minus 6x. X times x squared is x to the third. X times minus 4x is minus 4x squared. Draw the line, change the signs, add, and get nothing. Here we get 3x squared minus 6x. X squared goes in there plus 3. And I don't even need to worry anymore. I've got my equation. Y equals, it's an oblique asymptote, and y equals x plus 3. X-intercepts. They were 0, but that's a whole, so not. 1 at minus 2. Intercepts are points, so minus 2, 0. And at 3, 0. Y-intercepts, we put 0 in, and we get undefined, so there is none. And then sketch the graph. So we have a whole at 0, 1.5. We have a vertical asymptote at 4. And we have an oblique asymptote at x plus 3, slope of 1. No y-intercept. There is an x-intercept at minus 2 and at 3. So it looks like this is going like this, going to there, then it has to go through there, and then go down. And if it does that, and it goes at opposite directions at this one, it must come from up here someplace, way up here, and follow this that way. And you can check it by graphing it. Solve for when f of x is greater than or equal to 0. All of this is greater than or equal to 0. So that's from 4 to infinity, not including the 4. And it's greater than 0 from minus 2 to 3, except there. So we have to break this into two pieces. So from minus 2, including minus 2, because it's equal to 0, up to 0, union from 0 up to 3 and including the 3, union the rest. Oop. Minus 2 to 0, and then from 0 to 3 it's positive, and then beyond 4, it's all positive. Solve and round your answer to the nearest. So let's do base 10. So 10 to the log of 7 times, to the x, 7 to the x times 6, 10 log 6 is 6, equals 10 to the x minus 2. So we got x log 7, and when we're multiplying we add the powers, plus log 6 equals x minus 2. So I'm going to subtract this from the x and add 2 to here. So I'm going to get 2 plus the log of 6 equals x minus x log 7. On my calculator, 2 plus log 6 is 2.778 equals, and I've got 1x minus log 7x's, so 1 minus log 7 is 0.1549x. So I'm going to divide 2.778 divided by my last answer, and I get 17.934 is what x is approximately. When we subtract, we divide, so we have log base 3 of x plus 2 divided by x minus 5 equals 2. Changing it to a power equation, 3 to the 2, 6 equals x plus 2 over x minus 5. Multiply both sides by x minus 5. And we get 6x minus 30 equals x plus 2. Subtract x. Add 30. And x equals 32 divided by 5, which is 6.4. And 6.4 plus 2 is legit, it's positive, and 6.4 minus 5 is okay, so that looks like a valid answer. That's my check. Okay, we're given these h of 7, so you just got to put 7 here, so I have h of 7 would be undefined. It would be the square root of -10, which is square root of 10i. K minus g, k, 3x plus 4 minus g is going to be x, 3x minus 2x is x, 4 minus 7 is minus 3. F times g of minus 2. So I got to do f of minus 2 times g of minus 2. F of minus 2 is minus 2 squared is 4 times 3 is 12. 12 minus 4 times g of minus 2 is minus 4 plus 7. So that's 3, and this is 8. 8 times 3 is 24. And D, f of h of x. So I got to put h of x into f. So that gets squared, so I'm going to get 3 times 4 minus 2x minus 4. The square gets rid of the square root. So I got 12 minus 6x minus 4, which is minus 6x plus 8. The domain, so I have to be able to put it in here, so the 4 minus 2x has to be greater than or equal to 0. If I add 2x to both sides, I get 4 has to be greater than or equal to 2x divided by 2. And x 2 has to be greater than or equal to x, or x is greater than or equal to 2. So the main in interval notation would be from 2 to infinity. Oh no, excuse me, I turned that around. Less than, so negative infinity up to 2. Flipping that, x is smaller than 2. X is smaller than 2. Okay. Determine f inverse. So this is y equals 3x squared minus 4. So I swap x and y, so I get x equals 3y squared minus 4, and solve for y, so I add 4 to both sides. Divide by 3. And then I take the square root, so y, or f inverse of x, is the square root of x plus 4 divided by 3. And the domain has to be restricted to greater than 0, because this is a parabola. And to be able to do the inverse, we can't have, it has to pass a horizontal line test, so that has to be gone. So we're just doing this part. Determine the domain and range of the of f inverse. So the domain of this, what can x be in here? Well, it can be from minus 4, because that would make 0, from minus 4 to infinity is the domain, and the range is going to be 0 to infinity. Now, let's just look at what we just did. So I'm going to type in, oop, I cut off the screen there. I'm going to type in the equation 3x squared, clear, I messed that up before, 3x squared minus 4. So we're only going to use this part of this because we can't have it there. So we're only using this half. And if we do its inverse, square root of x, let's see, parenthesis, x plus 4 divided by 3. This part flipped over the y equal x is this part. So the domain is from -4 to infinity, and the range is from 0 up for this red line. So we could type it in and get this. Well, you can see here the domain was from 0, the domain of the blue, they restricted it right here to greater than 0, so that's what the range has to be for this, because the domain and range get switched. And the domain, the range for this was from -4 to infinity, so that becomes the domain. We're switching y and x, so the domain and range get switched. So if we're only looking at this, it was a domain 0 to infinity, so that becomes the range. The range was from -4 to infinity, so that becomes the domain. Okay, so we got y equals x squared. One, 2, 4. There's the parent function. And we're going to create a new one by reflecting the parent function over the y-axis, which leaves it the same. Looking on the graph, but what happens, oh, I got to put units on here, 1, 2, 2, 1, 2, 1, 2, but what happened is, to flip it over the y-axis, it has to be y equals -x squared, then shifting it up 2 units. So now it becomes up here, one, 2, 2, 1, 2. And so that would be y equals -x squared plus 2. So where does the point 2, 4 end up? Well, it moved over to here, so it went from 2, 4 to -2, 4, because it got flipped over, and then it got moved up 2, so it ended up as up 2 would be -2, 6. So this new point is -2, 6. Sewage. When sewage is dumped into Lake Gitchigumbi, the concentration of algae increased from 1,000 cells per milliliter to 8,000 in 4 days. So this is a growth model, so went from 1,000 to 8,000. So if we divide by 1,000, we get it's 8 times as much as what e to the k t, and t was in 4 days. So writing this in base e, it's e to the ln 8 equals e to the 4k. So ln 8 divided by 4 has to equal k. This has to equal this, and so if I divide by 4, I get this, which is so k is equal to 0.5198 or 99. So we determine the value of k. Determine a number of days for the algae to reach 1 million. Starting with 1,000, and so the k is staying the same, 0.5199 times the number of days. So if we divide both sides by 1,000, a million divided by 1,000 is 1,000. And if I write this in terms of base E, then this has to equal this. So all I have to do is take ln of 1,000 divided by 0.5199, and that will equal t. So ln 1,000 divided by my last answer, and I get 13.29 days. And how much after 1 week? With that's 7 days, so I just go back to my original formula. With this is my k, and so starting with 1,000, e to the 0.5199 times 7 days to find out how much. 1,000 e to the 0.5199 times 7. 38065. Per milliliter. All right. Population of rainbow trout in Bear Lake is 5,000 and decreasing. Determine the number of months for the population to drop below 4,000. So 4,000 equals 5,000 e to the negative 0.075 t. Divide by 5,000 and we get 4/5 equals e to the negative 0.075 t, which is, and this is just 0.8. So ln, if I write this in base e, it's e of ln 0.8. So ln 0.8 has to equal 0.07 negative t. So I divide ln 0.8, close parenthesis, divided by negative 0.075, and I get 2.98 months. Determine the population 6 months as predicted by the model. So I just put 6 into t in this. 5,000 e to the negative 0.075 times 6. 6 months? Yes, 6 months. And I get 3,188 trout. Okay. Determine the center. So we have x squared plus 8x, completing the square. Half of 8 is 4, squared is plus 16, minus 16, plus y squared minus 6y. Half of minus 6 is minus 3, squared is plus 9, minus 9 equals 0. This part is x plus 4 squared. this part is x minus 3 squared. Add 16 to both sides and 9, I get equal 25. So the center is at minus 4, because it's moved, the plus 4 moves it, minus 4. The minus 3 moves it, plus 3 in the, oh, this is y, plus 3. And this is the radius squared, so r equals the square root of 25, or 5. Equation for this, it crosses at minus 1, at 2, and at 5, but it's a bounce here. So the equation would be x plus 1 squared, x minus 2, and x minus 5. And it has a y-intercept of 2. And if I put 0 in here, I get 1 times minus 2 times minus 5, which is plus 10, and it's supposed to be at 2, so I have to divide by 5. This one bounces at minus 2, goes straight through at 4, and it looks like it has a horizontal asymptote at 20, 10, 5. So to bounce at 2, that means x plus 2 must be in the numerator. To go through 4, that means x minus 4 has to be in the numerator. And to have a vertical asymptote somewhere in here, like maybe 0, you would have to have x there. And it goes the same direction on either side, so it's x squared. And looks like another asymptote at 3. So that would be x minus 3. The degrees are the same because this is 1, 2, 3, x to the third and x to the third. To have a y-intercept of 5, or horizontal asymptote of 5, we'd have to have times 5. And we can check that. But I believe that is correct.